All right, so let's go to example 1 now, and we're going to follow those 5 steps we just talked about. All right, so first step is we're going to solve, or remove everything to one side. So here, we're going to subtract 15 from both sides here. So we get 2x squared plus x minus 15 equals 0. Well, sorry, greater than 0, I should say. Greater than 0. All right, so we're dealing with that. So that's our first step. Now, after this, we're going to go ahead and go to step 2, where it says that we're going to set this equal to 0, and we're going to solve this out as if it were actually a function instead of actually inequality. Okay, so we know we're going to factor this down, and we're going to use, what some people would say bottoms up, some of that sort. We're going to factor it, so we have the 2 parentheses, 2 brackets. And I'm going to go ahead and do the what some people call the X factor, or they have so many different names for it. So what I'm going to do, I'm going to do 2 times negative 15. So 2 times negative 15 is negative 30. And then underneath here is understood 1. So we can put 1 down here. So what we're going to do is we're going to multiply, see what multiplies to give us negative 30. And what adds to give us 1. And with that, we should be able to see really quick, that should be 6 and negative 5. So 6 times 5 is 30. 6 times negative 5 is negative 30. But if we do 6 and a negative 5, it gives us a positive 1. All right? So here we have x plus 6, x minus 5. But then the other thing that we must do is divide by the leading coefficient. And so here, that would give us x plus 3. This would give us x minus 5 over 2. And one thing that we need to do before we go ahead and say this is our factor, we need to go ahead and do the whole thing that they call bottoms up, which is we take this denominator and we move it in front so that it actually is the factor of it. And so we're looking at our factors of x plus 3 and then 2x minus 5. So if we were to multiply this back out, that would give us that 2x squared plus x minus 15. The 5 over 2 won't give us back that original answer that we had there. All right, so here we get this part, and we said we need to go ahead and solve it out. So we're going to, now that we factored it, we're going to do a zero product to principal here. Oops, zero product to principal. Set them both equal to 0. And so we get x equals negative 3, and we get x equals positive 5 halves. All right, so that means those are our boundary lines, our boundary points. So those are our boundary points here. So when we do this next step, we're going to be using those to actually solve out what's going on. And I spelled boundary wrong, sorry. Maybe put that A right there. Boundary. All right, so we have that. So let's go with step 3 now, sorry. And we're going to put those boundary points on the line, on a number line. Now, depending on some places, they'll want you to put like -1, -2, -3, all those things down. What I need you to do is just do this. And also, again, if you are planning on going to AP Cal, this is really wonderful because this actually helps you with when we talk about things for concavity, areas of concavity, intervals and everything of increasing, decreasing. We use this process for it. So this part right here with our boundary lines and the actual next part we're about to do. So here we set this up for our boundary lines. And so with that, we need to go ahead and, well, we already put them up, and that's what step 3 said to do. Let's go ahead and put it here. So place the solutions on a number line. That's our boundary points, which we just did, step 3. Now, when it comes to step 4, we're going to test these. So what we need to do For step 4, we're going to actually test these out. All right, so for step 4, we're going to test these. And again, we're going back to step 2. So I'm going to put that equation out down here really quick. All right, and some places they actually do tables here. You can if you want to. I'm not going to do a table. I'm just going to go ahead and do this part here. Just write it out and everything. But here we're going to test each one of these areas. So we're going to have to test this area here, test this area here, test this area here. Or what I like to say is, let's go and put our intervals here. Negative infinity to -3. From -3 to 5/2. And then from 5/2 to positive infinity. Okay, so with that, at those points and everything, that's where it's like equal to 0. And we're not looking at where things are equal to 0. We're looking at where things are actually, let's see, we said earlier, we're looking at when it's actually greater than 0. So we can't have it equal to 0, so we can't have brackets because it's not looking at where it's equal to 0. We're looking at where it's actually greater than 0. So we have 5/2 here to positive infinity, and we're using parentheses for that point. All right, so with this, we're going to try a number that's between negative infinity to -3. We're going to try a number that's between -3 and 5/2. And then we're going to try a number that's between 5/2 and positive infinity. So here, just to, let's see, let's try something easy. So let's try, let's do -4 here. Between -3 and 5/2, we're going to try 0. And between 5/2 and infinity, let's try 3. Because 5/2 is 2.5, so let's just try 3. All right, so we're going to put this into the calculator. And we're going to put, sorry, let's not use that. So we're going to try -4 into the function. We're going to put that into the calculator, and we're going to see if it's positive or negative. So here, oh, that should be a blue, so I'm looking for. All right, so we're going to try, and when we say try, that means we're going to put -4 in for x. So we're going to put it in for x there and see, okay, what value does it give us? Is it a positive value or negative value? So if we try -4, that will give us an answer of, and actually we can go ahead and get rid of this part here. We don't need that equal to sign. All right. So here we're going to get an answer of 13, which is positive. All right, and since it's positive, that means that we're looking at the parts that f of x is greater than 0. And now with that, I'm going to go back to what we just talked about with the steps and everything and go back and kind of talk about that really quick. So we said if it's positive, that means x is greater than 0. When it comes to the answer, if it's negative, it means x is less than 0, which makes f of x is less than 0. F of x is greater than 0 for if it's positive. F of x is less than 0 if it's negative. Which makes sense because in our problem, we're looking for where the f of x, which is this function right here, is actually greater than 0. So anything that's going to be greater than 0 here is going to be part of our solution set that we need. So we automatically know right here that so far, negative infinity to -3 is going to be part of our solution set because that's where it's greater than 0. All right, so let's try, I think it said 0 for the next one. Yeah, let's try 0 in the function. So if we try 0 into the function, if we substitute that into the function, that means we're going to get -15, which is negative. Which is not what we need, because we said that we need where f of x is greater than 0. This is where f(x) is less than 0. So we don't need that one. All right, and then we said we're going to try also 3 for that last segment into the function. So let's try that really quick. Okay, when we do that, we work that bad boy out and everything. Let's see, we will get an answer of 6, which again is positive. All right, so that means, again, it is f of x is greater than 0. So since it's greater than 0, that's another thing we need. So for this part, the parts that are greater than 0, to match up with what our problem said, will be this section here and this section here. So we need to actually write down this section right here because I didn't write it down. Sorry about that. So this section here was from 5/2 to positive infinity. So when it comes to our solution set, and this is actually now our step 5 was to actually find a solution set. So our solution set here is negative infinity to negative 3 and 5/2 to positive infinity. Because those are the parts where it is greater than 0, which is positive. All right, so we're going to do the same things for the next 2 problems. We're going to find pretty much going to put everything to one side. We're going to solve it out. We're going to find our boundary points. We're going to test them. And if it's positive, it matches what we need. If it matches what we need, we're going to use that area. So with that being said, let's move on to our next one.